up to today? Well, this is almost a repeat of a previous video. Now, you may or may not recall, depending on how much of a fan you are, I made a ring recently out of recycled white metal with a tube of tritium gas in there for luminescence. I did that for my wife. Now, a good friend of mine who has a great deal of experience in the jewelry industry has decided she'd like one too, and in fact quite a number of people have decided they'd like one. So at some point I'm going to have to ask money for these things, but for the time being I'm doing a couple of freebies. And so I've skipped the whole laser cutting montage this time, and we're going to go into a bit more detail about how actually everything is done in this one. So we'll see how we go. I'm not sure actually how this piece of label here is going to affect things, but we'll see how the mold goes together all the same. But yes, let's get these mold sections out and I'll go into detail about why and how and the intricacies of that. Okay, so we're going to go to the mold assembly. Now this is a method that I've come up with myself over several years of development. So let's see what we've got here. This is the mostly critical part here. This is the part that actually forms the end product, which of course will look something like this. And the advantage of this is you end up with a little blank you can test on fingers. And of course I'm dealing with people who have the tiniest fingers ever. But anyway, so that goes in there and this bit goes in there. Now the advantage of doing it this way is when I'm finished, I can take it out, give it a quick polish and sand and put it back in here, and that gives me something to hold it while I Dremel the inside. Now I should probably make a ring mandrel, or I could put this in a vise or a lathe if I really had to, but the Dremel method seems to work just as well. But in any case, that's our critical bit. Now I'm going to make one crucial change here, but I'll show you how everything goes together first. So for that we need some nuts and bolts, of which I have a big box full right beside the camera here. Now my late great brother bought me like several hundred of these things before he departed us, and so I'm still using them. Now these are great. These are stainless steel hex head bolts with a smooth shaft. Now the smooth shaft is kind of crucial in that it helps keep these 3mm holes nice and concentric. So we notice we have a flat bottom here, and I'm leaving the glue from the label side on the bottom so it doesn't interfere with everything. So we'll test assemble this. I'm just going to use 3 bolts for now because we need a 4th one in the middle. So this is the bottom layer of our mold. So of course we're going to insert this piece here, and that creates basically creates the hole through the middle of the ring, and then this bit goes on next. And so there is a change I'm going to make, and I'll show you in a moment, but we'll test assemble everything else first. This is our main pouring sprue, and you'll notice there's a couple of additional holes there. Again, we'll put the label up. We'll be coating with all of this with graphite powder and working it in with our hands to help lubricate everything, so that we don't end up with a problem. Now I'm going to rotate that 90 degrees, by the way, so it doesn't, or more like 60 degrees, so that we don't end up with one of these pouring sprues over the top of the clasp at the top, or claw. Now I'm having some trouble here because I need to be doing this in a different order. We need to get one at a time. Trying to watch through a camera and do this all at once is a bit of a challenge. Now we'll see here there's a bit of an offset in here. I wonder if I've got enough light to see that. I have one over here somewhere. Where is a light? My light has gone MIA. That's typical. Here it is, it's on the other side. Okay, so we can see in this hole here, or maybe not, so we can get close to camera angle, you can see how there's a slight overlap in that hole. That's intentional. It gives me a lip and a gauge to sand down to, or to cut with flush cutters. Now these parts I'll add more screws in for, but these, as you probably guessed, go on the top here like this. And they stack up progressively, and they make a nice header on the top, which I'll need to find which way these were cut so I get them in the correct position. So these will gradually stack up here, And that means when I pour metal in, it creates a bit of hydraulic pressure, which is almost the same as the centrifugal mold, which I'm going to have a crack at making at some point. And then on top of that, I'll put a bund of blue tack as well, just to get a little bit more metal on top of that. But mostly these bits are here to help protect the screws, to stop getting white metal in the threads or blue tack and whatnot. It means I can reuse them. And so yeah, so let's pull this apart now that you've got the idea of how everything goes together. And I'll show you a modification that I'm going to make. So let's get this pulled apart and we'll be right back. I'm going to take my Leatherman here and I'm going to take out the sheep's foot blade on it. Now this is a trick I've learnt from some people who do big metal casting with the same metal, but some people that are very experienced at it. So if we take out our central mold here, now I'm going to put a scratch along here and here, maybe around the edges. Now if you just, even in the metal molds, if you just put a little scratch, that's enough just for a tiny bit of air to escape, and that will mean that the metal will fill fully out to the edge of these little prongs here. Because by the time it gets there, it will have cooled a little bit and it'll be a little bit more viscous, and even then it will still be quite hot. It'll behave much like water. So I'm going to lean around the camera to do this. I'm just going to put a little scratch at a nice high angle like that. That's literally all you need to do, and it creates a little cavity that the air can escape from. I'll continue to do that in several places around here as well. And that just allows a little bit of air out. And literally that's all you need to do. And crucially, when I put the mold together, those scratches will be at the top side, which means the metal can pool at the bottom and it will fill up from the bottom and force the air out the top. It seems a little counterintuitive, but I have found when I put it up this way, I don't get the same results. I get bubbles forming at the top. So, metal being significantly more dense than air, it does tend to want to sit right at the bottom, and it will force the air out these gaps. And that's what we want. And from here, these are just two small holes. Rather than having a big hole the size of the ring, this is just to help me cut it off and trim it off and differentiate where it's from. So yeah, rather than having a big long column size ring and cutting sections off, which might be a method if you want to go to a lot of effort, but I just want to make one, not like 50. However, if I were to do multiples, I could just as easily make a stack like this with multiple side by side, or I could do multiple layers stacked, which would also work, but I do find doing them in parallel rather than series seems to work a lot better. So from here, I'll do a little bit more mucking around, and we'll see how we go with the rest of the mold. Alright, so this is a test assembly, something I don't normally bother doing. I normally just put it all together and pour the metal. Now, the observant among you will notice this gap here, and yes, metal does occasionally pour through that. However, normally when I assemble these, I will offset those a step each time. That slows it down a little bit. They are separated such that when I take these bolts out and I have a solid slug of metal here, I can pull them apart whilst this is still in the pudding phase, and then I can remove those screws and I can tap my spatula through there and chop that off. Now I'm using a mild steel screw in here instead of a stainless one, because I probably won't get that nut or that bolt back. I might get the bolt, but they're usually full of white metal by that time. So I usually just throw that back in the pot, and that nut will float to the surface because it's less dense than the white metal. So yeah, but that's pretty much it. The next step now will be to work the graphite into it and get some metal hot, and then we'll do some work from there. We'll shine it all up, polish it up, and we'll drill the hole. Now there's a hole that's got to go into this, and I will just show you momentarily the drill bits that I'll use for that. Okay, so I've been using circuit board drills, which are for drilling holes in circuit boards, as you might imagine, and they come in a range of different sizes with this uniform stock on them. Now traditionally I would use something like this, but I happen to have misplaced all the sets of jaws for it to take those size screws. So the very first one of these I've done, which was the only one that I've done to date, I used my hands. I literally took one of these and I worked it through by hand. But the problem with that is it took forever. So these do fit my Dremel, so I'm probably going to drill a smaller hole with a Dremel at minimum speed, and then use my hands to work their way through the next bit. At some point I'll either purchase or make some new jaws for this. Now, why do we need a hole? Well, in case you haven't seen the previous one, I have a remaining tritium gas tube here. Now, these are a little gas with phosphor on the outside. They're glass tube, and they're about 1.5 mil diameter by about 6 millimeters long. And they are tiny and easy to lose, as you can see. But what we'll do here is, while we're looking at this, I'll push it to the center of the screen and we'll turn off the external light. And we should see it glow right there. See it glowing away there? It should do that for about the next 15 to 20 years without any exposure to sun, because there is some radioactive gas in there called tritium or tritium gas, however you choose to pronounce that. It throws off alpha particles, which for the most part don't penetrate the glass, but what they do is impact the phosphor coating on the inside of the tube, much like how a fluorescent tube works. And so, of course, as those particles hit that phosphor coating, it turns it into visible light. Now, the green ones are much more visible than the blue ones. I bought two here to see which would be the best, and as I'm giving this away for free, I gave the good one to my wife, and this one's going to get donated to the person mentioned at the start of this video. So if I can pick this between my fingers and get it into a focal zone, you might see a little better. But yes, these are a nice pretty blue, but not quite as noticeable as the green. That could be because the human eye is most sensitive to a green. So we'll put that back in its little housing there, and we'll turn some lights back on. And we'll turn on all the monitors above here. So that's going to go safely back in here till we need it. So let's explain why that's relevant. So you saw the initial shape of the ring, which I can't get out at the moment. Those two little prongs at the top, we're going to take our drill here and we're going to drill through one of them, and then we're going to make a small indentation on the other side there, which is just enough to hold that tube in. We're then going to drop the tube all the way through, and we're going to use a pin to drop a little bit of glue into that indentation there, and once that starts to hold, then we'll drop a few more drops down the hole to fill that up and secure it. Now, I did have some ideas of using some gallium metal here to plug the hole, because its melting temperature is vastly lower than the white metal that I'm using. The problem with gallium is it tends to react and work its way through things, so chances are that that would end up over time working its way through the tin every time the temperature got above 30 degrees, and it would make it really fragile and crumble and fall to pieces. So I don't really have any metal that has a melting temperature significantly lower than this, so I'm probably just going to leave it as is. That, or I'll find a way to machine a small plug to put in there. But I think for the most part nobody's really noticed it, not the first one anyway. And so from there, yeah, we'll probably polish it up and finish it up from there. I do have some ideas of using some polyester resin to fill the gap between the two, but I think that might look a little epoxy. I think the idea with what I've got at the moment gives a sense of fragility, which is very much correct, which makes it feel more valuable. That and the fact that tritium gas is about $30,000 a gram, so there's not very much in there, but it's more expensive than gold and diamond, so you can sort of boast about that, I guess. But anyway, it's now the middle of the night, so you guys are going to have to probably wait until the next morning to see the rest of this, but fortunately in YouTube time, the next morning happens somewhere about now. And right now is actually a bit of a lie. I thought I'd stop for a moment. I rummaged around and I found my spare set of jaws which fit these drill bits. So I now know how I'm doing that hole. So we're happy. So let's skip another 12 hours and we'll jump to the molten metal part. Okay, so a couple of days have passed since we were last looking at this, and we're out in the shed. Now, the next step in this is to add graphite, but I'll do that in a moment. I'm going to run a second run as well. This one was actually a request, but a while ago I made a really dainty tiny little ring with knotwork around the outside. and that was a very technically challenging ring, much more so than this tritium gas ring. So I'm trying to repeat that action. So what I've done is I took, surprisingly, the back panel off. I think it was looks like that. Oh, that was. I've got a heap of these. These are video extender ballons. I just took the card out of the back. It was about the right size, and I've engraved a tiny little knotwork pattern onto this. Now there is an unwholesome amount of work getting the maths to stack up so that the patterns line up around the outer perimeter of this. This stuff also, once it's been heated to the degree of the laser, it doesn't tend to like rolling up. So this can be a challenge to get in here. So I'm going to assemble that, and that will be a secondary pour I'll do once I'm about to pour this one. So I'm going to go ahead and put this together, and then we'll put some graphite on everything, and we should be good to go. Right, so this is just a quick little quickie just to show you what it looks like with the pattern embedded in the edge of the ring there. So that'll be good. And what we'll have is a little centerpiece here held in with a screw to form the inner size, the inner diameter, and this will be about the size of the ring, which of course all these women have got tiny fingers. So yeah, it barely fits upon my pinky. There's literally no finger on my hand that this will fit on. So yeah. Alright, let's get all this assembled and get the graphite into it. Alright, and so this is the point at which you discover why this desk looks so messy. Because graphite is just messy by nature. We're going to rub it in with our fingers and get it into everything. It's just how things have to be. Now, there's a bit of a trick I use. Once I've done the first one, I get a little bit on my finger and run it around the inside here. I try and work it into these little prongs up here as much as I can, because that will help determine just how smooth that finish is. Try and get a little bit in there. Sometimes with a design it's not real possible. You just try and get some in there. So that will help the mold come apart. Now I do have my 2 scratches on the top there. That's good. That should let some air out. One of the advantages of making a mold like this that has multiple segments is you can do the screws up a little bit loosely, and it allows air out each gap. With a design like this, you don't really sacrifice quality by doing so. I'm not putting too much graphite on the middle bit here because this I'll be using this to help machine the ring, or help finish it once it comes out of the mold. So I don't want that to drop out too easily, but I don't want it to be permanently stuck in there either, because the metal I'm using is somewhat soft. So there's some graphite in this one, and here's our pouring space at the top. Now we'll do 1 nut on the top here. Whoop. Now, there's a particular reason why I'm putting things together in the order that I am, so that this means I can unscrew that screw at the bottom even if this is still set in molten metal, whereas the rest of these I've put them out the bottom so the metal doesn't gum up the threads. I need to rotate these around till we've got aligned holes, and we'll flip this up. Now that will wriggle back on there, and I'll put some screws on, and now we'll get some graphite into this and we'll be on our way to pouring metal. For the number 2 mold, I'm going to mount this slightly differently to demonstrate an older method that I used for mounting these or pouring them. I'm going to use some self-tapping Robertson screws here, or square drive if you prefer, into a solid hunk of MDF. This is because I can't fit 2 things in a vise at the same time. And this requires a significant amount of downforce, at least for the first one. And in actual fact, that's really all we need for this entire mold. And one of the reasons for that, I want to allow maximum air out there because I have such fine detail in there, and I'm not going to have a lot of hydraulic pressure on the top to force it in. Whereas this one, I've got quite a bit of head on it to force it into those little gaps. So yeah, we'll be looking pretty good. All right, we're about ready to heat up the metal now. Let's go do that. All right, now this is actually a pretty basic setup. I've got an old peppermint tin I've had for years. I've got a little cartridge gas burner. because they're cheap, and if I bugger it by melting metal, it's not too much love lost. Now the metal I'm using is recycled white metal from briquette press bearings. This one's a slightly different formulation. This is recycled with DSL. It's 9-pound ingots of the stuff. This I'm pretty sure is Microid X, but the colour in it tells me it's also a very high tin formulation. One of the ways I get the metal purified is I more or less overheat it in this, and then I skim the surface. The tin, being the more dense of them, will fall to the bottom, and the lead will fall even lower. And I'm usually skimming or pouring off the middle layer, so I'm getting mostly tin. In fact, almost 100% if I do it that way. It's flotation clarification just with metal. So it's an interesting little trick, but it does work. And I also get nice, shiny, silvery looking metal when I do that. Alright, let's sit around for a while and wait for this to warm up. Alright, so our metal is mostly molten now. It needs to warm up a little bit, and I need some gloves. So we'll skim the crap off the top in a minute, and you'll see it'll go nice and shiny under there. So let's get set up to pour. Okay, so it's D-Day, or the 11th hour, or whatever you want to call it. Going to pour some metal. The hammer is to make sure everything pours. Oh, hot metal on my legs. The hammer is to ensure that I get everything into the little details. And there's nothing special about this stuff that I'm using here. This is all just blue tack. Literally straight out of the box blue tack. It's a bit black looking because it's picked up some graphite, but that's literally all it is, and it holds up to about the 560 degrees or so that this stuff puts out. I wouldn't like to see it with gold or silver. It'll probably catch fire. This stuff does burn when it gets hot enough. So I'll keep my spatula out. I'll need that in a moment. But the hammer can go and hang up out of the way for now. Alright, we're going to let this cool for about 2 or 3 minutes. Then we're going to skim the top bit off. We have our mould open, and as we can see, it's poured beautifully. Alright, now to get number 2 out. Okay, number 2 is out, and it looks like it's poured relatively well. This will require a bit of finishing, but these ones always do. This is why I say they're technically challenging. Let's go back to the desk and pull these out properly. Alright, so now I've got to do a little bit of finishing work. And I'll take some flush cutters to this bit. And I'll probably sand these in situ in this. And that'll help me get a nice clean edge without too much burring. And then we'll go on to the manual stuff. This one here is a different case. I'm going to have to pop that out. And of course, I hit it too hard with a hammer while I was casting it. So it's just crumbled to pieces, which is annoying. So that sometimes happens. It's, this is fairly brittle stuff, so I got to that at a little bit the wrong time, but that was already secondary to the whole process. So yeah, we'll give you a close look at the end result of that. These come up quite well when they're polished, but again, I don't know if I'm going to go through the process of casting another one of them tonight, but that's okay. We have backups, so it's less work for me to do anyway. One of the other reasons I do refer to these as crush rings, because if you do happen to squeeze them, or you get your finger trapped, they crumble rather than bend and constrict your finger, which I think is a nice safety feature. I feel more comfortable wearing something like that in a workshop environment. So let's get this sanded down. I'm going to do that manually. It's going to take a while. I don't feel like doing another montage, so I'll see you once I'm done. Okay, we're all sanded. So what I did is I took it on a 300 grit on the belt linisher, and then I did an 800 grit wet and dry, and then I went to 1200 grit, and then from here we're going to tackle it on the rag wheel. I'm going to go at that, and for that I'm going to pop it out of here. It's the first time it's coming out, and we'll get a look at these top bits, which have come out very nicely. I'm quite happy with that. I'm going to leave this bit in here as it'll help me do the belt the rag wheel, and then I'll pop that out when I'm ready to do the Dremel on the inside. Alright, let's get round to the rag wheel. Alright, we'll adjust our camera angle slightly. So I'm using Josco iron oxide buffing compound. It's a bit coarse, but it works pretty well for this metal, provided you take a little bit of finesse with it and don't push too hard. So let's go with this. We're back at the desk. If you can't tell, we're going to give this a bit of a hand polish now. Just get some of the wax compound off it. I'm going to give you an idea of its final shine. I've got to be gentle with this because these are fairly fragile, as you saw from the other one. But this has a little bit more meat on it than the other one. The knotwork ring was designed to be as dainty and as light and flimsy as I could make it, but it comes with structural issues. It's like using a tent when you want a brick house. You don't always get the same performance. Alright, so it should be starting to shine up. This is the roughest side. This should be the nice clean finished side here. Some shine on it. And we'll do that bit in a minute. It's time for the Dremel in the middle now. And I don't have an exact ring size for the recipient of this, so it'll be interesting to see how it goes. Okay, so looking nice and shiny and feeling nice and smooth on the inside. Looking like almost like it could be silver, and it sounds like that when you drop it too. Alright, so let's go and put some tritium gas tubes in this. And I mix tritium and tritium because I'm not sure of the pronunciation. Somebody will Google that and correct me, I'm sure. So, unlike the first time when I did this and I used my bare hands to do this, I'm using my little driver this time. And I'm going in at a 1.2 mil first, and then I'm going to go in at 1.6, this being 1.5 mil. And in practice, they drop through just nicely. You know, I had a few jigs floating around to do this last time, but I found the easiest way was to do this with an Aussie pole stick and a blue tack, for lack of a better way of doing this. And that allows me to get a nice, accurate center mark right there. And that should let me go right through the middle. Right, now I'm going to turn the camera off for this because I need to concentrate. Okay, so the first hole is drilled. I'm going to go across here and I'm just going to make a very, very small recess in there, just as a locator for the other end of the tube. And this has been measured such that there should be at least 0.5 millimeter of the tube buried in either side. So that should be good. But we do need just a small little reservoir for the glue on the other side. Okay, now this is the tricky bit, and it's going to be a slightly longer sequence because I cannot afford to get disturbed. Now, a little trick I learnt when working with hearing aids is how to apply super glue. That is about 1,000,000 times more than what I need right there. So we're going to pick up the tritium tube, my wooden tweezers. I'm going to drop it in this hole here, and it should just drop straight in. Now this time I'm going to check that it actually is in that notch. Yes, it has sat in there nicely. Okay, it's sitting well. Now let's hopefully we can wick some super glue around here without disturbing its position, hopefully. And now we need to wick a whole bunch into the back of this hole, just little by little. It's a little bit like the method used in scientific studies where they use a pipette. They use surface tension to bring it through, trying to get it to wick down that hole. Also gives it time to set as it goes. So we'll keep going, and keep in mind I'm doing this with my bare eyes. I'm not using a microscope or anything to assist. Hopefully this one's fairly well set here. We can drop a little drop of glue in behind it just to fill up that recess that I've put in there. Now super glue does set more rapidly under humid conditions, and there is a storm front rolling in at the moment, so I think it's going to be quite humid, but I will blow on that with my breath in a moment and that will help. So we'll put our dressmaker's pin there. Alright, now we just have to let it sit for a bit, but what we'll do is we'll change the angle and turn the lights out and we can see it glowing. Now the camera picks this up relatively well. One of the reasons why this one is getting given away is this is the blue tube, and the human eye is a little less sensitive to blue than green. The green one shows up really, really brightly. This one not so much, but it should still continue to do that for a very long time. But nonetheless, this is demonstrating the principle to somebody who's got a great deal of jewelry skill. So hopefully this is impressive. We'll find out. But anyway, let's let this dry and we'll have a look at the finished product. Alright, so I've snuck into my wife's office and we see the first one I ever did here in the green and this one in the blue. And we'll turn the lights off and see what we get. So we can see there's a bit of candlelight here, but we can see the blue next to the green. And actually by comparison, they're not all that different intensity wise. But it looks like we've done alright. Alright, well that pretty well wraps it up. So yeah, let me know what you think of this design and what you reckon needs to change, if anything. And yeah, this video has pretty much been a repeat of the initial design, just with a few refinements. And but this one was for the benefit of the recipient of this actual ring here. So I'm going to make 2 more of these to give away to a couple of people that were first in on the requests. But after that, if anybody wants one, they're going to have to really either shell some money at me, or I'm going to have to really get to know them. Because, yeah, I can't keep making these for free. These little tubes, they cost me about 25 bucks a piece by the time they get here. This stuff is, the tritium gas in this is worth about $30,000 a gram. There's obviously not very much in there, but that makes it more expensive than gold and silver and titanium and diamonds even. So yeah, it's about as expensive as a setting that as I can put in there. But yeah, alright, I'll see you all guys in the next video, and yeah, I hope you enjoyed this one.